The question we're going to look at in this video is question 2 from the Free State Prelim Paper 1 from 2019. It's my own take on the memo, so it's not the official memo, but it's a really nice question because of the fact that the force being applied is a little different to what we perhaps usually see. So they tell you you've got two blocks, P and Q, there they are, resting on a rough horizontal surface. Now, by saying to me rough, that means friction is something I need to take into consideration. Light inextensible string, they're telling you that the force between them, the string between them, doesn't play a role in the acceleration or anything like that, okay? The blocks have masses of 5 kilograms and 2 kilograms respectively. Likely they put it on the diagram for us. And there's a constant force of F, we don't know what F is, acting at an angle on the 30 degrees, which is applied to the block, to the 5 kilogram block as shown. Then they tell you the two blocks now move to the right at a constant speed. What that means for us is A equals 0. So at the moment, F net on my blocks is 0. Okay, there's no resultant force. First question is to state Newton's first law of motion in words. It seems a little random because we've got two blocks, so you always automatically think that you're going to go to Newton's second law. But the fact is F net is 0. That's why they're asking for Newton's law, first law of motion. Okay, I'm just going to give myself some lines quickly because otherwise I can't write in a straight line. So Newton's first law says to us, and those are probably a little too small, so let's make them a bit bigger. There we go. Newton's first law. Okay. An object will remain at rest or, that's not all, that looks like R, or in motion at constant velocity unless acted upon by a non-zero resultant, you can also say net force. Okay, we're leading you into the next question, or into questions later on. Then they say draw a labeled free body diagram for P. Now it's worth 5 marks. 5 marks means there's got to be 5 forces. So let's just look at what we've got. There's always Fg, there's always Fn, there's F that's pushing it forward, but then there's 2 backwards. There's the tension in the rope from the Q, which is pushing it backwards, and there's friction. Don't put the components of the applied force in here. Okay, don't put the components of F. Use F as it is. So, free body diagram says to me, so this is 2.2, I have to have a dot. Okay, we've got Fg, we've got Fn, we've got Ft, which is the tension, and we're going to have friction. Okay, now with the force, remember the free body diagram, your force always has to be shown coming from the center. So even though it's pushing down, the angle that it goes to is that. Okay, now be careful when we label this. We don't say applied force anymore. This is the pushing force. It's not, we don't call it the applied force. Yes, we are applying a force, but it's a very specific type of applied force, so it's known as the pushing force. Then we've got Fg, which is gravity, F, which is friction, and you can also state this as static friction, Ft, which is tension, and then finally Fn, which is the normal force. Okay? Nice and simple. With Newton's laws, you're very likely going to get, in fact, I can probably guarantee it, a free body diagram of some sort in the question. Okay? Right. Now they say to you, block P experiences a constant frictional force of 2.5 newtons and Q 1 newton. So friction here is 2.5 newtons and friction there is 1 newton. They want the magnitude of force F. Okay, now we look at this and we go, well, I know F net equals 0. But if we think about it, I actually have two unknown forces. I don't know tension and I don't know F. Okay? So, I now need to sort of work around where I'm at, because I look at this and go, using straight with a 5 kilogram block's not going to help me. But if I consider the 2 kilogram block, the only forces acting that are relevant for this is Ft, which is pulling it forward, and friction, which is pulling it backwards. Now, what do I know? Acceleration is 0. So the resultant force acting on the 2 kilogram block is 0. Okay? That's important. So when we go back here, this is what we're doing. So for the 2 kilogram block, which is Q, I know that Ft goes in that direction, friction goes in that direction. I also know that F net equals MA, and this will be tension minus friction equal to MA. So Ft minus, what was it? They told me it was 1 Newton. Okay. Equal to 0, because A is 0. So my tension is 1 Newton. Now, on the 5 kilogram block, I'm interested in the horizontal forces. So I'm interested in the fact that I've got F horizontal from the pushing force. I have friction going backwards and I have tension going backwards. Just to remind you, so my F horizontal is here. Sorry, that's F. F horizontal is here, and that's 30 degrees. And F vertical would be here. Okay? So to get F horizontal, it's the adjacent side. So my horizontal force is F cos theta. In other words, it's F cos 30 degrees. So if I can find the horizontal force, I can find F. Okay? This is what I'm saying. F is my horizontal divided by cos theta. Okay? More than one way round we can do this, but now watch where I'm going to go with this. So again, F net equals MA. FH minus tension minus friction equals MA. F cos theta minus 1, we just worked that out, minus 2.5, that was given, equals 0. So F cos theta is equal to 3.5. We divide both sides by cos theta, and we get 4,041 newtons. So don't stress that you had two unknowns at the beginning. Because we knew what the acceleration was, yes, it happened to be 0, that's fine. We knew what the acceleration was, that makes it easier for us. So just do it one piece at a time. Don't get all anxious before you've actually even started the question. Okay, so now they say the string connecting P and Q breaks while F is still being applied. So the force of F hasn't changed. Is the direction of the acceleration on block Q now towards the left or the right? So if we go back to Q, I'm taking, let's get rid of all of this, I'm taking this force away. So there's no longer a force pulling it to the right, there's only friction acting on it. It is definitely a non-zero resultant force. Alright, there's nothing to counteract friction. That means Q's going to slow down. That means Q's acceleration is going to be to the left. Okay, it's going to be to the left. You have to answer the question. Okay. Yes. Q's going to the right. It's moving to the, and the acceleration is to the left. So, when I answer this question, it's going to the left. Why? Only friction is now acting on Q. Friction opposes the motion of Q to the right. Therefore, Q will slow down and acceleration will be to the right. Okay, last question. How will the net force acting on block B be affected? And they only want you to choose increase, decrease, and remain the same. So remember what we've done here is we took out this force. That means when we consider all the forces on P, this is what's happened. That force has disappeared. There's less force going to the left. That means the forces going to the right become more significant. When I go to F net over here, I'm not going to be minusing this anymore. That means my F net, because F stays the same. That means my F net has to increase. Okay, F net increases. Only worth 1 mark. Please don't spend time writing an explanation. Alright, you don't need to. If you need to work it out in your head and write on your question paper, go ahead. Don't write an explanation in your paper. You're not going to get any marks for it. Okay, hope that helped.